So, good day everyone. Today I will be solving the problems regarding crystallization for our CHE361 finals activity. I will go through each step. So, let's start with problem number 1. So, the solubility of a substance A at 25 degrees Celsius is 25 grams per liter. At 50 degrees Celsius, its solubility is 75 grams per liter. If 500 ml of a saturated solution of A is cooled from 50 degrees Celsius to 25 degrees Celsius, how many grams of solute A will be crystallized? Assume volume of solute in the solution is negligible. So, we have a solubility so we have 75 grams per liter, and our solubility at 25 degrees Celsius is 25 grams per liter. So our total volume of solution, we have 500 ml, which is 0.5 liters. So step 1 is to calculate the amount of solute dissolved at 50 degrees Celsius. So our mass at 50 degrees Celsius is equal to solubility times our volume. So our mass is equal to our solubility. So our solubility at 50 degrees Celsius is 75 grams per liter, multiplying to our volume, which is 0.5 liters. So in total, we have a 37.5 grams. So step 2 is to calculate the amount of solute that remains dissolved at 25 degrees Celsius. So our mass remaining is 25 grams multiplied by 0.5 liters, canceling liters, and we get the total of 12.5 grams. So to calculate the amount of crystallized, so we have to subtract our initial mass and our mass remaining. So in getting our crystallized, we have to substitute I mean we have to so in getting this, we have to 37 point minus subtract we have to subtract the initial mass and our mass remaining. So 37.5 subtract our 12.5, we get a 25 grams. So that is our number 1. Therefore, we have 25 grams of solute A will be crystallized. So our problem number 2, so a solution of potassium dichromate in water contains 13% of K2Cr2O7 by weight. From 1,000 pounds of this solution are evaporated 640 pounds of water. The remaining solution is cooled at 20 degrees Celsius. Number 2, calculate the amount of K2Cr2C7 crystals produced. So, we are given a solution for potassium dichromate. We are given the initial mass of solution, which is 100 pounds, and our concentration, we are given the concentration of potassium dichromate by weight, and our water evaporated, we have a 640 pounds, And our final temperature, we are given 20 degrees Celsius. So, in looking for our amount crystal produced, we step 1 is to calculate the initial amount. So, the mass of potassium dichromate, we have to get the mass of potassium dichromate. So, we have to multiply our 13% to our, so 0.13 is 130 pounds. Mass of water initial. So getting our water initial, we have to subtract our total mass and our, which is the 30 pounds. So we get 870 pounds. So calculate our water remaining after evaporation. So on getting this, our water remaining, we have to subtract our 870 pounds to our water evaporated, which is 640 pounds. So in total, we get 230 pounds. So assume solubility is 12.5 micromet per 100 pound water. So our max is, or 12.5 over 100 pounds of water. So canceling, we get 0. We have to also multiply this there by our water remaining. So we have 30 pounds. So we get 28 pounds, 0.75 pounds. So our next step is to calculate the crystals formed. So in getting the crystals, we have to subtract the initial solute and our dissolved solute. So our initial solute is 1, and our dissolved solute is the 28.70 pounds. So we get 100 pounds. So this is the answer of our problem number 2. So the next problem is to calculate the percentage yield of potassium dichromate crystal produced. So we have to calculate, and calculating our percentage yield, we have to get our crystal formed over our initial solute. Multiplying this to 100%. So our crystal formed is 101.25 pounds over our initial solute, which is the 130 pounds. Multiplying to get 77.88461538%, which 77.88%. That is our answer for. So the amount of crystals produced is 101.25 pounds and the percentage yield is 77.88%. So finally, let's move to our problem number 7. So a 1,000 pound batch of a 32.5% solution at 120 degrees is cooled without appreciable evaporation to 70 degrees Fahrenheit. What weight of magnesium sulfide 0.7 multiplied by 7 water 7 H2O crystals will be formed. C if it is assumed that the mother liquor leaving is saturated. Solubility of magnesium sulfide multiplied by 7 H2O at 70 degrees Fahrenheit is 26.3 pounds magnesium sulfide per 100 pound solution. So in total mass, in our given, we get our total mass, which is 1,000 pounds, is 32.5% of magnesium sulfide, and our initial temperature is equal to 120 degrees Fahrenheit, and our final temperature is 70 degrees Fahrenheit. So the solubility of magnesium at 70 degrees Fahrenheit is equal to 26.3 pounds magnesium sulfide per 100 pounds. So our first step is to so in getting this, we have to get the mass of magnesium sulfide. In getting this, we have to multiply the 0.325 to our mass, which is 1,000 pounds. So multiplying this, we get 300. We have, I was mistaken, we have the total mass of 10,000 there. So our total mass of magnesium sulfide is 3,150 pounds. And next is our total mass. So 10,000 minus our 3,050 pounds, we get 6,750 pounds. So next step is to calculate the maximum dissolved percent at 70 degrees Fahrenheit. Solubility is 26.3 pounds per 100 pound solution. So that means our solute is 26.3 pounds, and our solvent, which is the water, is equals to, we have to subtract our 100 pounds to our 26.3 pounds. So we get a 73.7 pounds. So the ratio 26.3 pounds over our 73.7, we get 0.356852101 pounds of magnesium sulfide over pounds of water. So our max dissolved, we have to multiply our ratio to our mass H2O. So multiplying this, so this is our max. Multiply by 650 pounds. we get 2,408.751696 pounds. So next step is to calculate our crystals formed, our magnesium sulfide. So our crystal formed is to subtract our mass magnesium sulfide and our max, which is the 2,408.71696. We get a total of 841.2830939 pounds. So next is to convert it. So our molar mass for magnesium sulfide, we have 120.37 G over mole, and our molar mass for our magnesium sulfate plus 7 water, we have 246.47 grams per mole. So in getting this, we have to multiply our mass of hydrate, which is the 401.24830339, multiply to our molar mass. So molar mass of our magnesium plus water per mole over our 120.37 pounds. So we get a total of we have a total of 1,722.542739 pounds. So therefore, the weight of magnesium sulfide plus 7 H2O crystals formed is approximately 1,722.542739 pounds. So that concludes my crystallization problems. Thank you for watching.